So now that we've learned what logarithms are and have practiced graphing them and working with them a little bit, we need to start talking a little bit about the algebra of logarithms. And specifically, that means we're going to have to learn some properties of logarithms. And this is the part of logarithms that can be a little tricky. The reason why it's tricky is the properties we get for logarithms. They're very closely related to exponent properties, but they're backwards. And whenever you try to do a thing backwards, it suddenly becomes really difficult, especially in this circumstance where you could maybe get it confused with its backwards relationship with the other one and do the wrong one. So the thing that makes them backwards is a thing that we were just using when we were talking about graphs. And that is that exponentials and logarithms, they're inverses to each other. We used that when we were graphing them, and it was a very useful fact for graphing them. And it's also going to explain why the logarithm properties come out to be the way they come out to be. And each logarithm property we've got, it's going to be related to an exponent property that you should already be pretty familiar with. Like, for example, the first exponent property I have here, you've used that all the time when you were back in Algebra 1. Anytime you were like multiplying any two polynomials together, you had to be able to do that multiplying correctly. Like if you did x cubed times x to the 5th, you don't get x to the 15th, you get x to the 8th. You add the exponents when you multiply two exponentials together. Notice that if I were to sort of describe the left and right sides of that equal sign, here I would say the multiplying is happening outside of the exponents. So I'm going to say that we are multiplying outside. And the adding is happening inside the exponents. The reason I'm being that specific about what's happening there is because when we go over here to the logarithm property, notice that the multiplying is happening inside the logarithm. And the adding is happening outside the logarithm. It's exactly backwards. It's the reverse of the other property. Multiply outside, add inside, versus multiply inside, add outside. So if you understand that exponentials and logarithms are inverses to each other, these properties will make more sense because they should be opposite to each other because they're opposite functions. Same idea is going to happen with this next logarithm property. And to be honest, this logarithm property we have here, this is probably the most important logarithm property of all. You're going to use this way more often than the other ones. It's the one that you use when you're doing word problems, when you're doing equations. It's the most important logarithm property of all. And again, let's do the comparison of what's opposite to what. Over here, you're doing an exponent outside of the other exponent. And that's producing multiplication inside the exponent. Well, we get the exact opposite over here. Here, the exponent is inside the logarithm. And the multiplying by the exponent is outside the logarithm. The rest of the logarithm properties are sort of easier than these two. These are really sort of the two key logarithm properties. The third logarithm property is really just sort of a reverse of this first one. If multiply produces add, then logically you wouldn't be too surprised that divide produces subtract. Let's see if I can get those on the same screen. There we go. So multiply produces add, divide produces subtract. Perfectly reasonable, logical thing to do. And if you really want to convince yourself, you can go back to the related exponent property where you're dividing outside the exponents, means you're subtracting inside, or you're dividing inside the logarithm, so you're subtracting outside. So that's not as hard to understand as the first two, because you can arrive at it two different ways, and they're both pretty logical. And then these two special simple logarithm properties, they're almost too obvious. Let me show you what I mean. This here, if you just translate using the definition of what logarithm means, what this is telling you is that the answer 1 is what you get when you take the base and use an exponent of 0. And that's true for any base. 2 to the 0 is 1, 3 to the 0 is 1, 10 to the 0 is 1, 8 to the 0, anything to the 0 is 1. So that's a very simple exponent property. It's a very simple logarithm property. And the same thing is true here. If you rearrange this into exponent form, you're basically saying that if you use an exponent of 1 on any base, you're going to get that same number. So 7 to the 1 comes out to be 7. Well, if 7 to the 1 comes out to be 7, then by the exact same idea, log base 7 of 7, or really any number that matches, will produce 1. There are some really common mistakes people make with these logarithm properties, and I need to tell you about them right away, mostly so that when you make this mistake later on, I can point you back to the video for 12.4 and say, watch out, I warned you, don't make that mistake. So one of the mistakes people make is with coefficients. When they have a coefficient on a variable, the mistake that people make is they do this. Feels right it's like some weird algebra instinct that just about everybody has. I remember thinking that when I was learning about logarithms too. Just about everybody who's in Algebra 2 and they're learning about logarithms, they think this is how this is supposed to break up. But it's not. And here's how I can show you the right idea. What does 5 times x mean? Think about it. 5 times x, or 5x means 5 times x. There's an actual multiplication in there. So we have a multiplication property. We learned that as our very first one. Multiplication inside the logarithm breaks up as adding outside the logarithm. So coefficients, don't forget, they aren't a separate type of thing. Coefficients are just a simple case of multiplication, and that means you should use the multiplication property. The other really common mistake has to do with this situation here. Again, very easy to misunderstand this, and just about everybody makes this mistake. I made this mistake when I was learning about logarithm. I think everybody makes this mistake at some point. And what's going on here is your brain is desperately trying to simplify things. And what it's doing is it's treating that log symbol in the front of the parentheses, it's treating it like it's a multiplication problem. But it's not multiplication. We are not saying something called logarithm multiplied by x plus y. That's not what's happening here. We are taking a logarithm of x plus y, which is really a totally different thing. So unfortunately, the bad news is that the logarithm of a sum or a difference, it doesn't break up at all. And there's kind of an easy way to remember that if I back up and show you an overall structure. If we go back to those properties, let me point something out. Multiplication broke up as addition. Exponent broke up as multiplication. Division broke up as minus. In a sense, what that's doing is it's reducing the difficulty level of the arithmetic. Adding is sort of a lower level than multiplying. Multiplying is more advanced, adding is simpler. Multiplying is lower level than exponents. So you're taking exponents and converting them down to mere multiplication. Division is being simplified down to subtraction. So in a sense, logarithms reduce the arithmetic level you're at. Well, with that in mind, what level is below addition? There's nowhere to go. You're at the base level, so a logarithm can't drop it down a level. There's no level to go to. So when you have a logarithm of a plus or a minus, it just frankly doesn't break up at all. You just leave it just like that. These properties serve a purpose, and there are two main reasons we study logarithm properties. One of them is a process called expanding logarithms. And what this basically means is use the logarithm properties to break this up into a whole bunch of simple pieces rather than one big complicated piece. And here's how it goes. Your first step would be to take this division here and using the property for division, break this up into a subtraction. So it's going to be log of the numerator minus log of the denominator. And then remember, each one of these is a multiplication. I'll put the multiply symbol in there just to make it really, really obvious. Multiply breaks up as plus. So this one here is going to break up as plus, and this one here is going to break up as plus. So here we're going to have log base 2 of x cubed and log base 2 of y squared. This one's going to be log base 2 of 8. This one's going to be log base 2 of square root of z. And you'll notice I've already pulled a very important trick. By putting these parentheses here, what I'm trying to point out to you is that this minus sign, it goes to both of those. Both of those will end up with a minus sign on them. Okay, what else? Let's see. We've also got an exponent. And the most important logarithm property, the one I made a big deal about, is the one that lets you take exponents and put them in front. So we're going to have 3 times log base 2 of x plus, take that exponent, put it in front, 2 times log base 2 of y minus, these will both come out negative. And then each one of these has something a little tricky that happens with it. You might want to pause the video and see if you can anticipate what I'm about to do. And then once I do it, if you don't understand, pause the video and try and figure it out. This one comes out 3, and this one comes out 1/2 log base 2 of z. So a fully expanded version of this would look like that. So make sure you see where that and that are coming from, because those are kind of the tricky parts of this. The other direction, the opposite of expanding logarithms, it's actually going to be more important. The idea of compressing them back together into a single expression, you'll find yourself using that actually more than you use this expanding logarithms ideas. So for compressing logarithms, you basically do everything we just did in reverse. These numbers out in front, put them back in as exponents. So you're going to have log base, not log base 2 at all, log base 5 of x cubed minus log base 5 of y squared, and then we'll put minus back together as division, and you've got log base 5 of x cubed over y squared. One of the kind of interesting things about compressing logarithms is there's sometimes more than one way you could do it. Like this problem here, I could have done this a different way. And what I mean is, when I brought in these coefficients, I brought in the 3 and I made it an exponent, I brought in the 2 and I made it an exponent, and that's where this came from and where that came from. I could have brought the negative in with the exponent here, to where I could have had log base 5 of x cubed. The minus would have been pulled in as part of the exponent, so we would have had y to the negative 2 instead of positive 2. And it would have been plus instead of minus. I mean, the minus was gone at that point, so it would have been adding instead of subtracting. So this would have produced log base 5 of a product rather than a fraction. It would have been x cubed times y to the negative 2. And for a second, that might look like two different answers, but then stop and think about it. What does a negative exponent do? Doesn't it put that down in the denominator and produce the same as that? Those two answers, although they look superficially different, they're actually the same answer, which is actually kind of confirmation that these logarithm properties work. If you use them two different ways, as long as you're using them correctly, the answers will come out the same no matter what. And then I got one last, totally for fun example, so if you want to just stop the video now, that's okay. But this last little example is to show you one of the kind of cute old-fashioned things that people used to have to do with logarithms. People didn't used to have calculators, right? They couldn't just grab a calculator to work out a logarithm. So what they used to have at the back of textbooks is they used to have tables of simple logarithms. You know, they'd have a whole table for logs base 2, they'd have a whole table for logs base 3, a whole table for logs base 4, and so on. And since they had to have all these different potential bases for the logarithms, they didn't want to cover every single possible number, because there's an infinite number of numbers. So what they would do is they'd have sort of like an abbreviated simplified list. And what you were expected to do with a problem like this, and notice, I'm not telling you what the base is because I don't want you to be distracted by that. I don't want you to actually go try to grab a calculator and actually work it out. What you would be expected to do with that is you would be expected to take the 75 and break it up into a product. In particular, if you were to factor out 75, you would get 3 times 5 squared, and you would be expected to do logarithm expanding. The multiply breaks up as plus, the 5 to the 2, you could go ahead and write it like this, but in just a second you're going to take that 2 and put it out in front, aren't you? So if you're good at this, you could do both of those steps at once. You could say log base b of 3 plus 2 log base b of 5 all at once. You don't really have to take multiple steps there. And then what you would do is you would look up in the table logs of these small numbers. Log base b of 3 is a fairly small number. It's probably on the table. So 0.792 plus 2 times, and you'd go look up log base b of 5, 1.161, and then you would do the actual arithmetic from there. So that's an old-fashioned technique from before the invention of calculators. And in those days, expanding logarithms was really practical and you used to have to do it all the time. Nowadays, not so much. Really, the only place where we still use expanding logarithms is calculus now. Compressing logarithms is still going to be important. You're going to find us using that later in this chapter here. So if you're going to practice one of the two directions more than the other, practice compressing.